Hi all, here's an example of solving a literal equation. These tend to look really messy and intimidating to people, but we do use the exact same tricks we use to solve our other types of equations. So it's important to make sure you pay attention to what variable you're solving for and where it's showing up in your equation. This one we're supposed to solve for b, so I need to notice that I do have more than one b, so I have to not only isolate b, but also get down to a single b before I'm done. Okay, so I would go for my clear mess right away. In this case, the mess is a fraction, so let's multiply both sides of the equation by a bc minus a. So ab plus c over bc minus a will get multiplied by bc minus a, and a will also get multiplied by bc minus a. So basically the step here is clear fractions by multiplying both sides by the least common denominator. It becomes really easy when there's only one fraction because that means its denominator is the least common denominator. If you need the reminder, you can always put this over 1. So on the right-hand side, we have a BC minus A. I'm sorry, on the left-hand side, we have a BC minus A in the top and the bottom, which means we get to cancel. We're left with an AB plus C. On the right-hand side, we don't have anything to cancel, so we're just going to have to multiply A by the BC minus A, and I'm going to go ahead and do that in this step. We can distribute. The reason that I think I will want to do this is because I'm solving for b, and as it stands right now, b would be stuck in the parentheses, so I think it's a really good idea to clear those. Okay, so checking back in, we're solving for b. Always check back in and see where your b's are. It would not be good enough at this point just to isolate one of the b's. We have to make sure we get them on the same side. Try and boil this down to a single b and then isolate. It is entirely up to you which side you decide to move your b's to. I think I'm going to go ahead and move my b's to the right-hand side, but it is completely acceptable for you to choose to move them to the left-hand side. If you're moving your b's to the right-hand side, I'm going to take this entire AB term, since it's attached to C by addition, I'm going to subtract it from both sides. Moving both b's to the same side. So I do think this is an improvement, although it still looks really messy. B's are on one side of the equation. While we're at it, let's go ahead and move the a squared to the left-hand side. We're trying to isolate b's on one side of the equation, so we can put all terms with a b on that side and all terms that do not contain a b on the other side. This is subtracting a squared, so let's go ahead and add a squared to both sides. Okay, so this is a pretty good spot to be with literal equations. It is also a spot where a lot of people get stuck. I am trying to solve for b. I've managed to get my b's on one side. I've managed to get rid of all terms that don't contain a b, moving them to the other side. The problem now is, how do I get this down to a single b? Let me just side note a tiny bit. If this was a plain old linear equation, I wouldn't really be having any trouble, because I would say, all right, if I had, let's see what's equivalent, something like this, 7 plus 3 equals 2b minus b, I could go ahead and combine the b's. The coefficients are easy, but here the coefficients are not so easy. The coefficients are AC and A, and there's no nice way for me to combine the AC and the A as I would combine the 2 and the 1 here. The trick that you need to be on the lookout for, and it's good for more than just literal equations, we'll use it a lot, is you can actually get down to a single b by factoring the b out. So basically we just want to reverse the distributive property. We're going to pull that b out, throw in a set of parentheses. If we're factoring that b out, we'd be left with an AC minus A. The easy way to check and make sure you've done this correctly is actually just to visually look at this and say, if I distribute the b back in, will it turn it back into what I had before? So if I multiply here, I will get my ABC. If I multiply here, I will get my AB. This is looking good. Okay, so finally, I'm down to a single b on one side of the equation. I want to get rid of everything attached by attached to b. Since it's all attached by multiplication right now, we have this in factored form. All you have to do here is divide. So we will get that a squared plus c divided by ac minus a is equal to b. And this is our answer. This looks great. We have single b on one side of the equation. Double check and make sure you don't have a b floating around over here on the left-hand side. You're not done if you do. Just to point this out, if you decided to move everything to, what did we do? We moved all the b's to the right-hand side. So if you decided to move the b's to the left-hand side, you may get something that looks like this. So it's very similar to what I had. In fact, it turns out that it is the same as what I had. All your signs will switch if you move things to opposite sides. So the fact that the sign of the a squared, the c, the a, and the ac all switched is really a good thing. To verify that this is equivalent to the answer I got before, you could just factor a -1 out of the top and the bottom of this fraction. Which will switch all the signs back. And then you can say, oh, -1 over -1, I can cancel that out. And there's my a squared c over ac minus a, exactly as I had before. So do not worry if all of your signs in your fraction have flip-flopped, because that just means you could factor out those -1s and get rid of them. Okay, thanks.